Welcome to this episode of the AEC Engineering and Technology Podcast, a podcast dedicated to helping engineering professionals find technology that fits their needs. In this episode, I'll be speaking with Rob Otani, Chief Technology Officer of Thornton-Tomasetti and founder of Core Studio, about the role of artificial intelligence, or AI, and machine learning, or ML, in engineering. We'll discuss the evolution of these fields through technology, examine impactful case studies, and the integration challenges of AI and ML in engineering projects. With that, let's jump into today's episode. Rob, welcome to the show.
Thanks, Nick. Glad to be here.
And we've got another full conversation here with a lot of great talking points. So we'll jump in. Rob, could you give us an overview as your role as Chief Technology Officer at Thornton-Tomasetti and the founding of Core Studio?
Sure. So, before I was CTO, I've been a structural engineer, practicing structural engineer for many years. With an eye on obviously what technology can, significantly improve, or how it can improve our processes. And so the role was a new role within the industry. Actually, there wasn't, and there still aren't many CTOs in the industry in our AEC field. But we recognized that we needed somebody beyond the CIO who was making our, software run, to figure out, best practices in terms of using software, as well as, potentially building new plugins and, software to improve our processes as generally a structural engineering firm. So my role really is to, look at the landscape of technology that's available to us and figure out what the best practices are around those technologies, but then when it makes sense, to build our own software. So we have a whole applications development team, and that has, I would say, been a big part of how we got into machine learning and AI, was that, AI is a subset, I would say. I don't know if I say that. Maybe software development is a subset of AI. We started to get into it a long time ago, and it's sort of taken off since then.
And Rob, your background, right, from just the engineering to project management of structural engineering projects at Thornton-Tomasetti, right? I'm sure that domain expertise really helped a lot in trying to figure out this technology strategy for the firm.
Yeah, absolutely. So I would say, the most important aspect of, let's say building our own AI applications is the domain expertise, is to figure out how to use the technology or the tools of AI to solve real problems. And the only people that know about real problems is people that, like myself, who, have done very repetitive and, annoying things over the years, that we know that there's a better way of doing it. And so that was our first task when it comes to machine learning and AI, is to solve those issues.
And Rob, so for our listeners who might be new or don't really understand the terminology just yet, could you explain what AI and ML are in the context of engineering?
Yeah, I think the generic definition of AI is, a technology that replaces what humans do. But that's really, in my opinion, too broad, particularly in AEC. I see it as a technology that basically learns from information that you give it, i.e. data, and then that can solve tasks that a person does if they get the right data in the right format. So there's basically an input and output. So I'll give you, the simplest example, which is actually not that simple, but again, with domain expertise, it can be made simple or simplified, is, let's say I'm designing a beam in a building. There are probably 15 to 20 inputs that go into designing a beam in a project. The span, the dead load, the live load, the trib area or trib width, that sort of thing. the type of concrete that's on top of the deck, or the metal deck itself. So all these factors. But if you can narrow down that design space based on or data space, I should say, based on your experience, then you can narrow the inputs down to a very small number, a relatively small number, and create a data set that can be used to design that particular beam. So, and it's one of those things where, like, the first thing you do when you enter an office is, particular structural engineering office, you do design beams and columns. So if someone with 0 to 1 year's experience can design the beams and columns for the tallest building in the world, you would think that we can design a machine learning model that can do the same thing. And I'm not going to say it's easy, but the sort of the basics of machine learning, very structured data sets, you can do it. And that's what we've been working on in the last, 8 years or so on machine learning and AI. So we're getting to the point of having machine learning models that are almost as accurate as code-based designers, traditional software.
And Rob, so AI ML kind of been working on it for, it sounds like, about the past 8 years, but was there any event or anything in particular that inspired the shift?
Yeah, so one of my developers in 2015, that was about the time when machine learning started to become, I would say, well-known, at least in the technology firms, the Googles, Amazons, Facebook. First of all, they wouldn't exist without AI. That's what they did. That's the basis of their existence. And so I was like, what is all this about? And he explained to me that basically you take some smart solved answers, fit a curve through it, very much like, let's call it linear regression. Every engineer on the planet knows what y equals mx plus b is. And if you have a pretty clean data set, you can fit a curve through there, and then you ask it a series of questions, and you get an answer from solved information. Let's say I take the beam design for the last 1,000 buildings, say, which is very hard to do, but let's say that's possible. You're going to get an answer that is pretty close without doing anything. And so that what inspired me was like, isn't that what we do every day? But it just takes me 5 years or 10 years to, without even doing any engineering. Now I can probably size most elements of a building. But if we can sort of encapsulate that smart information into an application, and give access to that to the sort of everyone in the firm, then and it's accurate, and we have enough. Let's say we vetted it to the extent that it's accurate enough. That's very powerful. That saves us a lot of time in what we do throughout the day.
And it kind of sounds like, right, Rob, like you said, takes you 5 to 10 years, but you've been training, right, your not artificial intelligence, right, your human intelligence, and it it sounds like you're trying to teach a computer to basically do the same thing.
Exactly, and I tell people, I think artificial intelligence is a terrible name for the technology because they're real information, and I show a graph, a linear regression graph. I explain it to my people in my office. And I show, okay, if I ask, let's say, some engineering problem to the top, 50 people in our office, those answers will be clustered in a very small little subset of a graph, say. If you're taking the answers from the smartest people in the office and putting it into a graph, would you trust it? The answer is yes. You would still have to do your engineering and use your analysis tools to confirm all of that and get to the exact answers. But in terms of getting a head start to what the answer should be, that's very powerful for an engineer. Engineers typically today reinvent the wheel every time they do a new design. So instead of making the mistakes along the way and then learning that way, sort of going, forwards and backwards. Let's just get to the answer and then prove it out later with conventional methods.
And it's like we discussed earlier, right, Rob? It's like having a super powered like junior engineering assistant, right? Can get
Yeah,
you the information you need in a very timely manner, right? And just like anything in the engineering space, up to you to use your judgment to make sure that the information is valid.
right, right. And I think you know, the cool thing about AI now is that it especially with the large language models that have been released in the last year, it goes way beyond just the technical aspects. I shouldn't say the technical, but sort of like the calculations that we do in our engineering space. We've been experimenting with using large language models to look into building codes, and we ask it a question, it gives you an answer really quickly back. Looking at old reports, so it can look at, instead of like me looking at like 10 reports and getting bored, it can look at 10 million reports and give you an answer back based on those 10 million PDFs, say. So I think that's going to be where, to be honest, just like people, everyday users are using ChatGPT to get an answer quickly or a potential answer quickly. That's where it's going to be, I think, the most powerful, at least for engineers. It's going to give you answers, whether it's about what you're doing on a daily basis really quickly, as opposed to guessing or trying to find the right person in the office that is going to know that answer. We'll be just talking to a bot, basically.
And that's really right. It's derived, and that bot, right, was trained or is derived from essentially your brain trust in any company,
Yeah.
right? And
Right.
and that's the beauty of it, because if you can, right, if you're careful about how it's trained, right, you can be very selective about the information you're feeding it in, and so on and so forth.
Absolutely. And again, it's not going to solve every problem, but it will solve a lot of problems. And I think the other interesting part about it is we've been experimenting with our marketing team. So our marketing team has thousands and thousands of what we call project sheets, which are one or two pagers of project specific reports. Basically, this is the design, this is the project, this is the location, the architect, the engineer, the cost of the project, cost, construction cost, etc., and a nice little write up of that particular project. We've pointed large language models at it, and people now they can find representative projects for like RFP or RFQ responses, as well as resumes of people that have worked on those projects, and then basically semi-automates the response of what marketing team does, and they love it. It saves them so much time. And I will say though, I mean, there is some hallucination along the way. ChatGPT is great at making shit up. So what we've done is we've very much like Bing does. It gives you the references of those where it sort of extracted that information, that particular information, and then you can go back and verify that. But again, it's a head start. It's not meant to be the end all or the final product. It's meant to be a head start to get, our marketing people who maybe have been there only for like less than 5 years, get access to the people that have been there for 20 or 30 years, and have the similar amount of information that they retrieve.
Rob, you've touched on a couple, but any more you'd like to share of case studies or projects where AI and ML have been successfully implemented at Thornton-Tomasetti?
Yeah. The other is, one of the companies that we spun out as a startup called T2D2.ai, which started out as a R&D project in, I think, 2017 or 18. And we were able to, within a 6-month period, be able to train a model to detect a crack in concrete, using computer vision. And, we extended that training to, cracks, all kinds of exterior facade damages, spalls, exposed rebar, for different materials, rust, things like that. And then that was wrapped into a startup company. And so now they can do a building inspection in, fraction of the time that a person can do it manually, I should say. And so that is one case where it sort of changes the paradigm of how you do your work, which is something that I haven't talked about. And we're only at the beginning of the journey of AI utilization in the industry. So a lot of the AI solutions that you'll see, including T2D2, is replacing what a person does manually. There is going to be technologies out there that AI will create basically new ways of solving a problem, as opposed to just replicating what we've done in the past. So we're not there yet, but the fact that the technology keeps improving, seemingly daily, there's definitely going to be something out there that improves significantly what we do, how we do our work.
And you're right, Rob, coming from the restoration side of the business, right? One example I always give with something like T2D2, right? So instead of going to count cracks or quantify spalls on a building facade, right? You as a designer can spend that time thinking about how you may want to detail a repair instead of this incredibly manual and arduous task, right? And it just, like you said, it creates new avenues and new ways of doing things. Ultimately, I think letting engineers focus on what they excel at.
Yeah, and I also think it opens up. Again, this is where I think it opens up new opportunities. Where, if in the ultimate goal of what T2D is meant to be, it's meant to be like, going to your dentist every 6 months, right? Instead of not going to your dentist for years and finding you need to root canal and all kinds of procedures, you go there very often, because you can do this very often, low cost, but save a ton of money downstream. And so now we can not just do like an inspection on day one, but let's say let's say year one, year two, we can find figure out what the differences are and how the existing damage is accelerating or not, which is something that we don't typically do today because it's very manual. We're not looking at comparing crack to crack to crack or whatever that damage may be. So then that's another sort of aspect of, having a digitized version of what we do. There's new opportunities and value that we're creating using that type of technology.
Rob, any other thoughts on the use of AI and ML applications to increase the efficiency and effectiveness of engineering projects?
Yes. I would say one of the most untapped aspects of what we do is project management, which has a technical aspect, has a finance aspect, staffing, and personnel. When I say staffing, I mean the number of staff, but also the actual personnel. And a lot of all of that information is embedded in multiple different software, and sometimes it's not tracked at all. But if we can figure out the sort of secret sauce or the chemical makeup, say, of a profitable project versus a not profitable project, and see the cues of when certain projects might go awry. Again, it's just data, right? It's just being able to harness that data. We have the information, but it's usually locked in some platform that we can't get access to. I think that's where that's going to significantly improve what we do. I mean, I will say, the whole accounting and finance aspect of AEC is pretty archaic, pretty old technology. I mean, just started to release APIs for their data set, right? I mean, so once we start to get a nice sort of clean, sort of path of information streaming to us in terms of who the clients are, the type of projects, the schedule, the expenditures that we're spending on a daily or a monthly basis. Then you can take actions using that data set. Again, personally, I would start without AI. I would start with just using the data and, use data analytics first. But the predictive nature of AI can be layered on afterwards. And we've only just started that, understanding that, or even having the ability to do that, to be honest.
Rob, we've talked a little bit about, right, either the benefits of AI that are, right, in force today, what's coming down the pipeline, but what about some of the challenges of integrating AI and ML into engineering projects?
So, I would say my biggest challenge that I found is, particularly in the engineering space, is people are resistant to change. That's the hardest thing. But on a technical level, engineers need to have that comfort level that it's giving them an answer that they would predict themselves. So I've been very slowly going to office, or again, I gave a whole office-wide presentation recently, just educating people about what's under the hood of what we've done, so that there's no surprises. It's not going to get you to 100%, but then again, I tell young engineers, your answers are never 100% anyway. So once you get comfortable with what it's getting to you, and then you can pretty simply, or using conventional methods to check, then you can significantly leverage the technology as a tool. To do something that would normally take you 3 days, you can do it in 1 day, and be confident enough that it's something that you can move on to when doing some other task. So I think those are the biggest barriers. And I will say, just educating people about what AI and ML is. People don't even realize that they're using, or they're either using, or they're being, things are being sort of around them are using AI. They don't even know it, right? So I think making that shift of actually understanding what it is, understanding that how it can be used in your projects to improve your daily workflow, and then ideally coming up with new ideas about how this can be used. So we've been experimenting with, engineers love spreadsheets, right? Everyone has their favorite spreadsheets. We just started to take spreadsheets and train models from them, using their own spreadsheets. So they've already figured out the back end of what it's predicting. If I can get to 95% accuracy using their spreadsheets in a second, that they would have to enter a bunch of things, and I can use it on an entire building, say, as opposed to like one element, that's really powerful, right? So I think it's just getting that comfort level, understanding that this is like essentially Excel on steroids, at its simplest level. Then I think engineers will start to sort of utilize it as a technology,
And Rob, how do you envision AI and ML being integrated into like these everyday workflows of engineers?
Yeah, I think it's interesting, because I think there's been a trend. When I started my career, we had to sort of optimize what we did because we couldn't do a full building design. It was too arduous. We didn't even have 3D modeling software. It was like 2D modeling software. So you're not going to model the whole building anyway. I mean, literally, like SAP, you could do it, but it was a very manual process to get 3D elements, 3D node geometry into a model that you barely can visualize. So we learned how to do everything in 2D and then apply it to a three-dimensional object, the building. And I think over the last 15 years, engineers have become overly dependent on these 3D modeling software to the extent that they might miss exactly sort of like what's going on in their project. They're letting the machine do it all, which is okay if the machine is doing it right. But we sort of overdo it in early design phases of design. So like I know for a fact that we build 3D models in schematic design or like early design phases of design that's going to get changed 10 to 15 times, down to like the number of studs that are in a beam, or all that stuff, as opposed to using their sort of, again, engineering ability to be confident enough that they just design, let's say, 1 or 2 bays of steel framing or like a few columns to get a sense of what those sizes might be, as opposed to doing an entire building analysis. And I actually think AI and ML can foster that in the early phases, like almost going back to what we did in the past, which is solving subsets of the entire building and using our own AI, our own brain, to feel comfortable with that. This is going to work within the entire three-dimensional building. Which again, I'm an advocate of 3D. So we can do the subset of that design, but still do a very beautiful, fancy 3D model, for visualization and for delivering our design to a client or an architect, without going through the process of a very arduous 3D FEA modeling exercise. So that would be my goal, at least first for the next 5 years, is to sort of automate those early design processes.
And then, Robin, some of the tools that you've shown me, right? Let's go back to that 15 parameter beam design we discussed earlier, right? Maybe there's a chat GPT-esque interface, right, that asks for a couple basic parameters, right? And hey, here's a typical interior, bay of a steel structure, right? And you're just able to generate very rapidly, but at the same time, be able to do some quick math and calculations on the back end to verify it, right? Like that to me sounds more of like an SD level. Hey, like let's get this thing roughed out because we know it's going to change as like the design team iterates.
Yeah. I mean, the other thing too is I think because of how good essentially the software have become, the FEA software, including their modeling techniques, but also their designers, their code-based designers. Engineers are so reliant on those. But the reality is what the clients need at those early phases. They don't need to know all that very specific detail. They need to know broad characteristics of how deep is your structure, how many pounds per square foot is your floors, those types of things that you don't need to do a full engineering design to figure out. Now, there's some experience that goes with that to the extent of how much you need to do these little subset design explorations. But that's what being an engineer is. If you're going into the computer model and letting the computer do it, you're not really an engineer. You're being a data entry person, right? Letting the machine do all the work. But the fact that we spend 30 to 40% of our fee, or at least that's the allotment of our fee, typically for those early design phases, if we can significantly cut into that, then we can do a better job at our final design deliverable, but also just save money on those particular projects. That's that. I think that's the initial goal. The next 5 years. That's what the big goal is.
And Rob, for those either coming into the profession or those already in who are interested in specializing in AI and ML in our field, right? What advice would you give them?
I think training. I took some classes, weekend classes, online classes. I've taken online classes around AI and ML, just to understand what are the ingredients to it, to best leverage the technology, what it can do. But I think the combination of using a machine learning tool, and also understanding the basics of what goes behind the engineering principles is going to be the sort of most important aspect of, the future engineer. I go to what Jensen Huang said from NVIDIA. It's something about, AI won't take your job, but someone who knows how to use AI will. And I think that's really true. Like, even now I use ChatGPT for summarizing, a nice little paragraph of text or whatever, or searching for a write-up of whatever. And it does it so fast. And its English is way better than what my English can do. Let's face it, engineers take like one class for expository writing or whatever, right? ChatGPT has done it. Has done it on billions of data points. So it's going to write an English report way better than an engineer can, or most engineers, I should say.
Absolutely. Rob, thank you so much for joining us today. If the audience wants to connect with you, right, find out a little bit more about what you do, AI, ML, et cetera, like, what's the best way to reach you?
Probably LinkedIn. I'm pretty active on LinkedIn. I check it every day. It's a good place to, find, people and companies that are doing interesting things. And that's how I think that's how I met you, at least through some other channels, through Shadow. But that's probably the easiest way.
Which is great to hear, right? Because as we see AEC, people, companies, et cetera, become more popular on LinkedIn and other social platforms, right? It just helps the knowledge sharing and getting everybody right to the same end goal, essentially.
Absolutely. And look, I learn stuff, I wouldn't say every day, but quite often on LinkedIn, like what people are doing in this space. And look, I think that's part of keeping ahead of the robots, is to learn something new every day. And LinkedIn is not the best platform, but it's a platform that there's a lot of new information that comes out. And the more you're connected, the more you're going to see posts. And so that's to me, that's the best way to get connected with like-minded people.
Absolutely. And Rob, thank you so much again for joining us, and we'll catch you next time.
All right. Thanks, Dick.
Please remember, you can find the show notes for this episode at aectechpodcast.com. There, you will find a summary of the key points discussed in today's episode, as well as links to any of the resources, websites, or books mentioned during this episode. Until next time, I wish you the best in all of your engineering and technology endeavors. Thank you.